Okay, we're looking at the review sheet here for trig graphs test. And number one, we're going to try to write, so we ask you to write both equations here, so that way you make sure you get to do both types of phase shifts. Position, sine and cosine are important. The native position of sine. Hold on. I don't have my drawing tool up. Now I can put it up. Oh, actually, that was kind of nice though, wasn't it? All right. So if we think about position of sine, we know that at the normally at the y-axis, it's at the midline of an upslope. At the peak of one of the waves, that's for cosine. So we're going to start out. No matter what, you need to know what the midline of the wave, what the amplitude of the wave is, what the period of the wave is. That'll be the same no matter sine or cosine. So you kind of find those first. Okay, so we're going to take a look at the period, or we're going to look at the midline of this wave first. So I'm going to take the average of the maximum value and the minimum value to figure out the middle value. So if I take 1 plus 2, I get 3. Drawing that midline of the graph is almost, I mean, it's very important to me because it allows me to now look for native positions when the graph is at a midline and when it's not. Okay, so looking at that, looking at the next piece. So now I know that the midline is at 3, at y equals 3, okay? And then the amplitude, once I have the midline, now I can tell what the amplitude is. The amplitude is from the midline to the peak, and it's a distance, so that's a 2. Amplitude of our native amplitude of sine and cosine is 1. Now we have an amplitude of 2, so we can tell that we've been stretched by a factor of 2. Period. Here, I need to know the horizontal distance between 2 corresponding spots on the wave. And on here, the easy spot is I can do 2 corresponding minimums. So I know those are corresponding spots. I know the distance between those would then be the period. 12. Also, since all the symmetry going on here, if I know that, you know, this is really 4 equal pieces here of a wave. So right there, right there, right there, and right there. So if I know the length of any one of those pieces, you know, midline to peak, or peak to midline, or midline to valley, if I know the length of any of those pieces, I can just multiply by 4, and I can tell the total period. So if you notice, each one of these pieces is 3 long. So if the period is 12, okay, that means that the B value is 360 over 12 if you're graphing this on your calculator in degree mode, or if you're using degrees. So that's going to be 30. Okay, oop, not 30 degrees, sorry, 30. So that means that every unit represents 30 degrees. We're going to move on to the phase shift. So we know that both equations, so y equals and y equals, will have a stretch factor of 2 because the amplitude is 2. And they will have vertical translations or midline shifts of 3 because we got to shift the graph up and down 3. Now for the sine equation and the cosine equation, both of them, this kind of structure here, the B value is going to be 30 in both of them, because no matter if you call it a sine or a cosine wave, the period of the wave is still 30. There's still 12, which makes the B value 30. And now I need to do my phase shift. So for sine, again, let's see, what was the native position for sine? It was swoop. Okay, so I'm going to go, I'm going to find where I'm at on my wave, where am I at midway up to the upslope. Here, no, midway down on a downslope. Here's midline on an upslope right here. So I have to take my native position of sine, which is right there right now, shift it. So I need to move it -2, x minus -2, so +2 in here. Now for cosine, sine is right here. It's at a peak at the y-axis. So I need to move it over to a peak. I need to move it to this spot right here. So that means I have to move to the right one. So in my equation, this has to be minus, because it's always minus, and then, so x minus 1. So there's our equations. There's a sine equation and the cosine equation. Move to number 2. I've got a couple different ways. I'm going to write 2 equations, one for secant and one for cosecant. But kind of the same process applies. I need to know the midline of the graph. So if I look at this graph, the middle of this graph, let's see, from 3 to -3, from here to here, the middle of that is 0. So what that tells me is that we have a midline at 0. That is the native midline secant, so that I don't have to do a plus at k at the end at all. If I think back to native secant and native cosecant, either one of them, the distance between the axis of the wave and the bottom or of the u's is 1. We can look now to see what we're dealing with. We're dealing with 3. So kind of the amplitude is 3. Midline is y equals 0, so we don't need to move it around. How about the period? Okay, so the period, so I got to go between 2 corresponding spots. Here's a corresponding spot. So the distance between those 2 to 6 is 4. So the period is 4, value equal to 360. That's the native period of secant and cosecant. So that's going to be 90. So my b value is 90. All right, so now we're ready to write the equations. So we have y equals, and y equals, have been stretched by 3. A secant equation. One is going to be a cosecant equation. So we know all those pieces. We know that there's a +0 at the end of both of them, so I don't need to worry about that. I know that the b value is 90. So that's the same in each one. And now I have to do my phase shift. So I got to think about native positions of each one of these. The important pieces of this graph of secant and cosecant is asymptotes. So if I look at the middle of a bottom of an upper and the top of a lower, okay, the middle of that will be an asymptote. So I can see that there's going to be an asymptote there. There's going to be an asymptote here. There's going to be an asymptote here. And again, those asymptotes are important to draw in, so because they're an element of your graph that kind of helps you orient yourself around where this graph has been moved. So we're going to look now at what the native pieces of these are. So let's see, secant, if I look at the secant graph, native position is at the bottom of an upper when we're on the y-axis. So I need to find the bottom of an upper on my graph. So the bottom of an upper, I can either go over to this point or I can go back to this point. Either one doesn't matter. I'm going to go to this one. Right now, my equation without a shift is here. Shift it over. I need to move it over 2, so, and it's 2 to the right. A +2 shift. All right, so now let's get rid of my secant idea. and talk about cosecant, cosecant has a native position of having an asymptote at the y-axis followed by an upper. That followed by an upper is kind of important because if I look at, I could say, well, no, here's the asymptote. It's been shifted from the y-axis to the left one. Asymptote that's followed by a lower. So this isn't a cosecant. We could call it negative cosecant, but it's definitely not a positive cosecant in there. So I have to find an asymptote that's followed by an upper. So if I look here, my graph looks like this. It has an asymptote at, my equation has an asymptote at 0. Now I'm going to go over, I need to move it to 1. So those are my two graphs for cosecant and for secant, and my equations for secant and cosecant. Okay, so now we're going to move to the next piece. There are two problems where we ask you to graph. And by the way, remember we changed this to +4. Change that piece to +4. In fact, I'm going to do that a little differently. Actually put it on the problem. And the reason why we changed that to +4 is because when I drew my graph or my axes for you, it's really not, you can't really do a -4. If you had to do a -4 axis, that would have been kind of ugly. Get our landmarks done. We'll do our vertical landmarks first. We know that the midline of the wave is at 4, so I'm going to have to come 3 off of up at each wave. So I'm going to put my 4 here. And I'm going to put, again, I like to have that dotted line in there. Okay. And I got a 3 for my amplitude. So I know my wave is going to deviate 3 above and 3 below. So I'm going to go down here to 1 to 7. Again, I just try to match it. I just try to make sure that I'm equal on both sides to kind of help the graph a little bit. If I notice here, now I talk about phase shift. Shift of 25. And what's my period going to be? Because now I got to kind of landmark myself on the x-axis, 6. So my question is 360 divided by p has to give me 6. So I think the p has to be 60. Equation, my p has to be 60. Period has to be 60. So I'm going to put 25 on here because I know I have a phase shift of 25. So I know that point's going to be important. So let's see, I'm going to put 25 there. And now the next piece that's going to be important is 85. And I don't want to run out of room on my graph. I'm just going to come over here. I'm going to say, okay, here's 85. And then I'm going to add another 60, and I'm going to make sure I go the same, make this look the same so my wave doesn't get all funky, 145. I know that this probably doesn't look like 25 compared to this, but deal. Now we're going to look at what do we have going on? Well, we had a phase shift of 25 when we're talking about the native sine values. So let's see. At 25, I need to be at a middle of an upslope. So I'm going to draw that in. I'm going to draw that. I'll draw it in red. Draw my graph here. And I'm going to middle of an upslope. That tells me that at 85, I have to be at the middle of an upslope again. Then at 45, I'll have to be at the middle of an upslope again. Now, to get kind of the other pieces, now I use symmetry. So if I go, the middle of 85 and 25 is 45, is 55. Yeah, 55. So I'm going to go the middle there is 55. And The middle of 55 and 25 is 40. And the middle of 55 and 85 must be 60. I think those are all right. Let me just double check with my calculator instead of my feeble brain. So 25 plus 85 is 55, that's right. So then plus 25 divided by 2, I'm just finding the averages, 40, that's good. So then it looks like every 15, this is 15 is a fourth. So if I divide this wave into equal parts as well, and I go by 15s, 85, the next one here will be 100, 115, 130. So we get all those set on there. Great. So now we've got everything kind of set up. Now I can kind of keep going back to my graph. So I know that this thing's going to go up and then back down. So I'm going to be at a down swoop middle here. I'm going to be at a down swoop middle here. I'm going to be at a peak here. Here. I'm going to be at a peak here. Valley here. So again, I get those points knocked in. I get those, and then I graph it. Try to do it as smoothly as I can. And now, do I have two full cycles? Well, let's see. I get back to my original spot once. I get back up to my original spot twice. Okay, get back up to my original spot once. Get back up to my original spot twice. All right, so there's my 2 cycles. Moving on. The next one is based on the same concepts, but now we have some variables here. So because we have those variables on our X and Y axis. Okay, so what do we know? What's not variable here? What kind of numbers can we get in this thing? Well, we got a number here. What's that tell us? That tells us the midline is at 4. Let's see, I'm going to put 4 right here. Okay, so I have a midline of 4. What do I know? Let's see. I know that I have A for an amplitude. So I'm going to just say this up here. This distance is A, so this spot on the y-axis must be 4 plus A. Because I was at 4 and I'm going up A. This one dot here, because it makes it look like a negative 4. Yeah. Those things are weird. And then what would this spot be out here? Equal distance apart. We know it's going to be equal distance. It's a wave, so this would be 4 minus A. If I wanted to figure that out. All right, so now what else do we know? Oh, right here, let's see. We have a B value of 45, so 360 over the period is equal to 45. So I think that means my period has to be 8. All right, so the period has to be 8. Phase shift though, my phase shift is M, so I have to orient where M is on the axis. So it doesn't really matter where we decide to put our M. I'm going to put it in the positive. We could put it in the negative, but I'm going to put it in the positive. So we're going to say this spot right here is M, because that represents our phase shift. When will we have another? Well, let's talk about this. So now we have cosine. So that the native position of cosine, peak. So that has been shifted over to M. I'm going to be at a peak over there above M. So I'm going to be up here. I'm going to be at a peak here. I'm going to be up at a peak. Well, I'm going to be at a peak 8 units later. Here, I'm going to put another spot here. What am I know I'm going to be at another peak. And then what's that going to be? Well, if this was M and this is 8 to get to the next spot, this is M plus 8 in that location. And then if I go another 8 over to get another peak, the same distance here to here, whoops, same distance right to there, that spot right there will be M plus 16. Okay, so Now we got to get the rest of our kind of points set up. All right, so let's see. So midway between here, I know I'm going to be at a midline. I'm going to use red again for my graph. So I know I'm going to be there. Between here, I'm going to be back at the midline right there. No, sorry, I screwed that up on you guys. Midway between two peaks, you're at a valley. Here. You're going to be at a valley here. You're going to be at a valley here. Then midway between the valley and the peak, you're going to be at a midline. You're going to be at a midline here. The midline here and here. I'm just trying to get those targets done. So now I can draw my graph. All right, do I have 2 cycles? Let's see, I've got 1 cycle to get that and then another cycle. So I got 2 cycles of my graph. I can make this come down on this side if I want to make this go down. That's it. If I want, okay, let me put little arrows because we know they're going to continue. All right, now where are these spots? Let's see. What's midway between these two? So if I add those up, I'd get 2m plus 8. So that spot would be m plus 4. You know, there's 8 between here, so halfway would be m plus 4, and then this is m plus 2. This is m plus 6, or every dot, every increase is really 2, so this is m plus 10, plus 12. This is m plus 14. Going out from there. One. Again, using period, using your knowledge of symmetry and waves. Important there. All right, we got an average temperature in various places. All right, so this is our claim. We do want to draw a graph of the situation. Whoops. Draw a graph of the situation. And it says that, what do we got to have on here? Let's orient our x-axis or our y-axis first. We have to go up to 80 and 60. Okay, so somewhere, so here's 80. And it says, so the midline there is going to be, add those up, divide by 2. So the midline is going to be 40 across because that makes it easier for me. And then it says, draw it as it's starting at its lowest point, so that time 0, we're here. We have another low point, 20,000 years. We're going to come over here and say this is 20,000. In fact, I'm going to even go further out because I really only need 1 cycle of the wave to be able to write the equation. So 20,000 there, so this is 10,000 in the middle. Here again, I know that I'm cutting waves. This is 15,000. I know that I'm cutting waves in a half and a half and a half. I'm cutting it in a half multiple times. Marks. I know that halfway between these two minimums is going to be a maximum, and then halfway between the maximum and the minimum, axis or midline points. So there's our graph. Okay, now the thing that we haven't done here is we haven't put here, this is years, average temp. We got to label our graph. All right, and now we got to write the 2 equations of the wave, one using sine, one using cosine. Well, if I notice here, I'm going to say this is a native negative cosine graph. I know the amplitude of my wave is 40, so I have a 40 multiplier. I know my axis of my wave. That's not 40 between there. This is 70 between here. Gosh, you guys are thinking, what's he doing? That's 70 between there. All right. So let's go back now. So then we need plus 70 at the end of that thing. Okay, and now we're going here for the B value. 60 divided by So I'm just going to simplify that. 360 divided by 20,000. I can multiply both. I can divide both by 10, and then I can divide both by 4 at least. So this is going to be 9 on top, and this is going to be 500 on the bottom. 9 over 500. And then I'm going to have x minus. If I use negative cosine spot, so I don't have to do an x minus anything, I can just do x in there. If I did do regular cosine, a non-flipped cosine, I would have to have a phase shift of 10,000. So now let's talk about sine. Y equals -4 sine. Oops, I don't know if it's -4. The negative is what flipped it over. I don't need that right now. 4 sine 500. I know I'm going to have something in there plus 70. So everything's the same. Now I got to look at my phase shift. So this is going to be x minus middle of an upslope. That's the native position of sine at 5,000. So if I put 5,000 in here, now I've got the sine equation. I'm going to move on to the last piece. A city average is 14 hours of daylight. Sorry, this is kind of in a goofy spot, but I'm going to answers to this up here. So don't ignore. Well, I made a sign right there. All right. So now up there, the city average is 14 hours of daylight in June, and 10 in December, and 12 in both March and September. Assume that the number of hours of daylight varies sinusoidally over a period of 1 year. Write expression for n number of hours of daylight. The cosine function let correspond, and 0 is January. So okay. So it's a little goofy, but I think we can handle it. Let's draw the graph. So we know that in June, it's at its 14 hours in June, so we know that's the high point. And then here, this is going to be the low point is 10 and 12 in the other two. So then this is 12, and that just happens to be the midline. That's kind of nice. So let's see, January, March, I'm going to put M there just to help me. March, April, May, June. Let's see. Does that say 1 or does it say 0? Let's look over here. P equals 0. That. Okay. So this is where we get a little ugly, but we'll mess around. Okay. January, February, March, April, May, June. So here's June. And then we know that's a peak at that point. And then I, so this is 0, 1, 2, this is 3, 4, 5, 6, and then 7, 9, 10, 11, 12. All right. So let's see, that's June, and now let's see, it said December was 10, so I'm going to go over here to 10. That's the low point, and then in, what's it say, March, we want it at a midpoint right there, and in, where else is the midpoint? September, so that's 9 there. Okay, so now you can see I'm getting a little off of my scale, but I got this wave going on, which looks like full wave yet. I don't have a full, because I have a, this is one of those points where I don't go back up to the midline. So we got to think about this. So this distance right here, and double it, I should have a full period. So that's 6 months. Oh, that makes sense. So your period is equal to 12. Amplitude is equal to the distance from here to here is 2. The distance between those two is 2. And let's see the axis. So the midline is y equals 12. Okay, so now I can write my equation. And we want the cosine function function. So I have to target this point right here. Native cosine is a peak, so I got to target that spot. So I'm going to have amplitude is 2, cosine, and then here I'm going to have 360 over 12, which is 30. X minus x minus the phase shift, which is 6, plus 12. And that'll be my equation. If you have questions, you can definitely come in the morning of the test. No, actually, yeah, if I'm around, in 2016, I'll be gone for the morning. So you can call me if you need to.